All right, so today's notes we will title Arc and Angle Measures. And when we're looking at angle measures in or with a circle, that you want to pay attention to where the vertex is. And it will either be inside your circle, it'll be on your circle, or it'll be outside the circle. And so I'm gonna make a little chart here and organize this for you, and hopefully you could see some patterns that might help you out. So we'll start with our first category being on the circle. Then we'll look at in the circle. And then outside the circle. And in particular, we're talking about the vertex of the angle. This is the vertex on, in, or outside. So on the circle, we have one case that we have looked at quite extensively, and that's the inscribed angle. So here's an inscribed angle. Let's say this is measure of angle x, and it intercepts this arc. Call it angle y. And what have we learned in this case? What's the relationship between x and y? Y is double x, or x is half of y, either way, right? So I'm going to write this. So x is half of y, or you could write y is double x. There is another case that's on the circle that we have not seen. I'm going to give it to you. And that's the case where you have a tangent and a chord meeting at the point of tangency. So here's your tangent. And here's your chord. It forms this angle x here, and it intercepts this measure of the arc y here. So again, I'll highlight the angle in green and the arc that it intercepts in yellow. And I could take the time to prove all these results to you, and I consider doing that. And the proofs are fun and enjoyable, and I like them, but they don't help you in terms of what you need to be doing in this class and the types of problems. And so I made a decision. I'm just gonna show you the result, and I'll let the challenges be the problems that I give you on the homework. Okay, but here's the result. And if anybody really wants to see why this is the case, I'd be happy to go over it with you. They're not tough proofs, but you get the same result, and that's the key thing I want you to see. Both angles have a vertex on the circle, and the relationship between that angle and the arc it intercepts is exactly the same. That angle is half the measure of the intercepted arc. If you're in the circle, say we have two chords intersecting somewhere in the circle at this point, okay? And let's look at this particular angle here. So this is going to intercept two arcs, one in front of that angle and one behind the angle. And so this is the angle I'm looking at. And notice that the vertex is not on the circle, but it's inside that circle. So because it intercepts two arcs, we're going to have to involve both of those arcs. And I'll let z be the larger of the two and y be the smaller. If x were, the center of the circle, then both z and y would be the same measure. And it works at the center and it works anywhere else, which is nice. And here's the relationship. You get x is 1/2 z plus y. So you add up the measures of those two arcs and divide the sum by 2, and you end up with the measure of your angle. And then there are 3 cases outside the circle. So one case is if we have 2 secant lines, and we haven't talked about secant lines yet, and I'll define that for you. But a secant line is just a line that touches or intersects the circle 2 times, where a tangent line hits it 1 time. So these are secant lines. And here's the angle I'm after, x, and it's going to intercept 2 arcs, a bigger one here I'll call z, and a smaller one here I'll call y. You can see them a little more clearly. I will highlight our angle green. And when your angle's outside the circle, it would be smaller than if it were on the inside. And so to come up with x, it's going to be 1/2 z minus x instead of plus x. Sorry, y, not x. Z minus y. Okay. So in all these so far, you have x equals 1/2 something. And that something deals with an arc that it intercepts. In some cases, it only intercepts 1 arc. In other cases, it's intercepting 2 arcs. If it's inside, you're adding those 2 arcs. If it's outside, you're subtracting those 2 arcs. Another case outside the circle is if you have a tangent line and a secant line. Again, same angle, x, intercepting z and y. And you get the same exact formula. X is equal to 1/2 z minus y. In the last case, is when you have 2 tangent lines. And again, you get the same formula. So those are all the cases that we'll encounter other than, well, these are the types of angles you'll encounter with circles. So 2 types that were on the circle with a vertex on the circle, 1 type with the vertex in, and 3 types that are with the vertex on the outside. And since I'm mentioning the word secant, let's jot down that definition. So a secant line is a line that intersects the circle at 2 points. So I'm going to give you some examples that kind of mix these up and are a little more not as straightforward, not just plugging it into a formula, but you got to think a little bit around it. But it involves these formulas just to see what kind of problems you're going to be working with on the homework and on the test. Okay. So first example. I'm going to tell you that the measure of angle AEC is 120 degrees. The measure of arc CD is 80 degrees. And I'd like you to find the measure of arc AB. Give that a try. All right, give you some time to write that down and think about it a little bit. So we are told what CD CD is 80. We're looking for AB. And we're given an angle here. So call that 80, that's X. And this angle right in here is 120. How do we find X? What do you find first? Not sure? How about this angle right in here? That's going to be 60, right? Because 120 plus 60 gives you that 180 straight angle here. Those are a linear pair. And this is an angle inside the circle, and so we know that 60 degrees is 1/2 the sum of the two arcs that intersect, so x plus 80. Right, and so there's an equation we can use to solve. Multiply both sides by 2, and you get 120 is x plus 80, and subtract 80, and you end up with x is 40 degrees. Anybody able to get there? Yeah? Okay. So that's an example of working with that formula inside the circle. Example 1. Let me give you a second example. I got 4 in mind for you. Okay, this next case, I'm going to give you a circle with 2 tangents. And I'm going to tell you that the measure of angle ABC Where's Elizabeth? There she is. So let's say that the measure of ABC is 60 degrees, and I want you to find the measure of arc ADC. Go ahead and try that one out. All right, so on this one, we got 60 degrees given to us. And that's all, right? And we're looking for the angle measurement of the arc from A to D to C. So x degrees out here. And do we know what that is? From the arc from A to C, the minor arc? We don't know that one. Maybe it will end up being 120, I'm not sure, but right now we don't know it. But we do know, like if I call this y, we do know that x plus y is what? 360. That makes a full circle. So y is 360 minus x. And so it's nice to work with one variable instead of two. So instead of using y, I'm going to use 360 minus x. And so then I solve for x, and it's easier to work through this, okay? So 60 is outside the circle. So 60 is equal to 1/2 times the measure of the larger arc, which is x, minus the measure of the smaller arc, which is y, but instead of y, I'm going to put 360 minus x. And because there's two terms in front of a minus sign, you need to be careful to put them both in front of that inside of parentheses, because that negative sign gets distributed to both pieces, okay? So I'm going to multiply both sides by 2 to get rid of the 1/2 and get 120 is equal to x minus 360 plus x. Could add 360 to both sides and get 480 is equal to 2 times x, and then divide by 2 and you get x is 240. And it worked out. All right, so again, there's another example using that formula, finding that measure of an angle outside of a circle. How are we doing? Okay, all right. Example 3. Here I'm going to give you a circle with a tangent and a secant line. And I'm going to tell you that the measure of arc ABD is going to be 200 degrees. And the measure of arc BD, say that's 100 degrees. And I want you to find the measure of angle BCD. So ABD is 200. And BD is 100. And we're looking for BCD. Do you think they found it? Possibly, yeah. Nathan? 40, 30, 30. I don't know. I haven't done it yet, so I'm going to find out right now. Anybody willing to share what they did to get it? Yeah. Okay. Like this. What you thinking? Anybody else do it that way? What did you do? Okay. Wait, you guys agree? That's an inscribed angle. Okay, keep going. Okay, what is, everybody answer this. What is angle D? We need to, and don't pretend you don't know about the 30, okay? What is angle D? Because this is an angle on the circle, and you have formulas for angles on the circle. It's half of the measure of the arc that it intercepts. What is it? 100. Because the arc it intercepts is the green arc, 200. So that's 100. So 50, 100, which gives us 30 again. So there, you could do it that way. Just don't put 90. You got to put the 100. Okay. And if you think of a diameter, what arc would it intercept? 180. So that would be a 90, right? If it's a radius. So that's, you can apply it to that. All right. Last example. So FED is 80. FED is 80 right here. BAF, all of this is 240, which means this right here is half of that, which means this right here is 60. And I'm looking at this triangle here, so 80 plus 60 is 140, so we got 40 left. So 40 is, that's one way. Did anybody do it a different way? Yeah, and there's other ways to do it, so I just did it one way. 40 is your answer.